Good day. For this video, I will discuss to all of you the load flow analysis here in ATAP software. So the purpose of this tutorial is to give you an introduction to the use of load flow analysis and to be able to simulate the network model and evaluate the system performance with operating under normal and contingency conditions. This module has the following objectives. The first one is to be able to specify the rating of all system components and input the supplied specification data. Second, evaluate the system performance of a typical power system network and simulate during normal and abnormal conditions using ETAP. Third, implement appropriate solutions in fixing the system problems. So in load flow analysis, we have here a load flow toolbar. So this will appear on the screen when you are in a load flow study mode. So the load flow toolbar will allow you to run load flow analysis, perform a load flow study, activate or deactivate the autorun, stop the calculation, specify what you want to display on the one-line diagram, open an alert view to show the critical and marginal values, open report manager, and open the load flow analyzer. So moving on, let's start running a load flow analysis here in ETAP. So once you completed the given network configurations, we may start or we may proceed to run a load flow analysis here in ETAP. So running load flow analysis, first, select Load Flow Analysis button located at the System toolbar. Load Flow toolbar, click the display option. So make sure that the power flows here is in ampere. And then click OK. Run the load flow here. The results can be seen here in the OLV. Click on the alerts view. Ayan. So, we may notice that the red colors are in critical conditions and in magenta color is under marginal conditions. On alerts view, the operating percentage should be 100%. So, if it is greater 100%, the elements are in overload condition. If it is less than 100%, the condition is under voltage. So the bus 4 is under voltage in here, which is its operating conditions or percent operating is 94.7%. And then the cable 1 is overload and the cable 2 is also overload. They have 165.6 percent operating and 149.4% operating. So the bus 5 is under voltage because its percent operating is 95% lang. So power system analysis can be conducted at two different scenarios. So the first one is operation stage and the second is the design stage. If the system is operating stage, the issues can be solved by reducing the load through turning off the unnecessary loads. On the other hand, if the system being analyzed is at design stage, the issues can be solved by adjusting the rating of the elements. So for the solution under operating stage, we may assume that the motor 1 and the motor 2 are the necessary loads, while the synchronous 1, 2, lamp load 3, and 4 are unnecessary loads. So just turn off this load and then this load. And then all the necessary loads are kept operating and the unnecessary loads are turned off. So by running load flow again, so notice that by reducing the loads, the analysis doesn't have any error. So click on the alerts view and we can see in here that we don't have any issues on this configuration. So this solution is only for operational stage. So under design stage, so ibalik natin siya sa dati. So under design stage, we run load flow again, and then yun nga, may different issues here like this. So assuming that the system is under the design stage, we need to add capacitor bank to bus 4 and bus 5 since they have issues here. So select the edit icon and then click the capacitor bank right here. Double click the capacitor bank and select the rating tab. So let's say change the value as 2 mVar per bank. So this is how you change it. And then we can add a low voltage circuit breaker here. In adding the rating of the load voltage circuit breaker here, we have here the manual computation for the circuit breakers, for rating the circuit breakers of capacitor bank is right here. So in B19, we can change the type here, which is the power CV, and then go to the library and then start the start to find the best suit rating for the breaker 19. So we have here an E4H under 48 and then 36. Click OK. As well as B20, ganun din. So change the type, which is the power CV, and then go to the library and then EBB E4H 36, 0.48 and 36. Click OK. So right there. So we may notice in the issues that the cable 1 is under overload condition. So the single phase system requires 2 wires, 1 conductor and 1 neutral. And 3-phase system requires 4 wires, so 3 conductors and 1 neutral. So the circuit we are working in this is in 3-phase. So to solve the issues in cable 1 and cable 2, change the number of conductors per phase from 1 to 4. As well as in the cable 2. And then run the load flow again to check if we solve these issues. So that's it. The elements colored in red earlier turned black, which means that the issues were solved. So to double check, click the alerts view and the errors were gone.